divisibility test. So there's quick tricks or divisibility tests that we can use to determine if a number can be divided by a smaller number. So our divisibility test. So we have 2. So if it can be divided by 2 when the last digit is even. That means when it's like 0, 2, 4, 6, or 8, right? If it ends in one of those, it can be divided by 2. Now 3. It can be divided by 3 when the sum of the digits is divisible by 3. So we take the number 21. So what we do is we can break it down into 2 plus 1 is equal to 3. And now 3 can be divided by 3, and we get a whole number, right? There's no remainder on it, right? Because 3 divided by 3 is equal to 1. So we know 21 can be divided by 3. Now 5, it could be divided by 5 when the last digit is a 0 or a 5, right? Those are good indicators that it can be divided by 5. Any other number, it can't be. And then for the numbers 7, 11, 13, 17, 19, we're going to use long division. So let's go ahead and take a look at the examples. Example 1, a local bakery sold 12 cakes in 1 week. 12 is divisible by which prime numbers? So let's go ahead and look at 12, right? So if we look at 2, well, it does end in a 2, so we know it's even. So it does check out, right? So 12 is even. So we would say, yes, it can be divisible by 2. Then we look at 3. Well, this is kind of like 21 in the sense of, right, 12. We break it down into 1 plus 2. That's equal to 3, which can be divided by 3. So 3 checks out. Now the next number would be 5. Well, it doesn't end in a 0 or 5. So that one does not check out, right? So just 2 and 3 thus far. And then we're going to continue on. And so we notice that 12, the only other number that is, right, less than 12, but that's a prime number, would be 7. Well, 12 can't be divided by 7, right? It would have to be 14. So this doesn't check out. So which prime numbers is it divisible by? 2 and 3. So now we can move on to example 2. So example 2, a painting business quoted a bigger job for $2,730 just for the paint. So 2,730 is divisible by which prime numbers? Well, we notice that it ends in a 0. So that means it's even. So yes, right? So that checks out. Then we look at 3. Well, we need to go ahead and add up the digits, right? So we can go 2 plus 7 plus 3 plus 0. 2 plus 7 is 9, plus 3 is 12, plus 0 is 12. Well, 12 can be divided by 3 because that's equal to 4. So that checks out. So 3 is a good one. So now we can look at 5. Well, it ends in a 0. So yes. So that checks out. Now we need to look at 7. This is when we start doing long division, right? For these bigger numbers. So let's go over here. 7 can go into 27 3 times. All right, we subtract, we get 6. Bring down the 3. Well, 7 can go into 63 9 times. Because 7 times 9 is 63. We subtract, we get 0. Now we bring down the other 0. Well, 7 can go into 0 0 times. So we just go ahead and do that. And we get 0. So we got 390. So we get a whole number. So we can say that it is divisible by 7. So that checks out. Then the next number would be 11. So 11 can go into, let's see. 11 can go into 27 2 times. We subtract. We get 5. Bring down the 3. Well, 11 can go into 53 4 times. That's 44. We subtract. We get 9. Bring down the other 0. Well, 11 can't go into 90 evenly. So this does not work out. So we can just go ahead and cancel that out. Let's go ahead and look at 13 now. Well, 13 can go into 27 2 times, because that's 26. We subtract, we get 1. Bring down that 3. Well, 13 can go into 13 1 time, so that's just a simple 0. Bring down the other 0. Well, 13 go into 0 times. So 2,730 is divisible by 13. Now let's look at 17 now. Well, 17 can go into 27 1 times. We subtract. We get 10. We're going to go ahead and bring down that 3. Well, 17. Let's go ahead and go 6. That's 42. Bring that over. That's 102. We subtract. We get 1. Then we bring down that 10. Oh, I should have put a 6 there. Because 17 times 6 is 102. That's where we got there. And then we have a 10. Well, 17 can't go into 10 evenly, so 17 does not work. So what numbers are we left with then? We're left with 2, 3, 5, 7, and 13. So we have actually 5 prime numbers that 2,730 can be divided by. So that would be our solution, is those 5 numbers.